stream to it, that URL will stay up. Oh, this meeting's being live streamed.
Got it. I'm gonna look at this. So let me just.
I'll give you it.
You're gonna get Inception.
I'm gonna.
You can set them up to intercept them, so you can preset a URL in YouTube.
Oh, look. Ooh. Very, very fancy copy. Oh, I'm so much behind. Oh no, oh no, oh no.
Oh yeah, you've got like 4 levels of lag there.
I'm so much behind. Hold on, I'm gonna just post these to appropriate radio groups.
Yeah, I need to.
Where is Steve? Stevie.
30 seconds here.
Yeah, it says up to a minute on.
There is a low latency mode, but it's rubbish.
Well,
Don't
this is
bother
just
with
using
it.
Zoom. Zoom's inbuilt.
Yeah.
I
know. Yeah, there's a setting in the YouTube stream settings though, but don't set it. It doesn't do any good.
Okay, the wiki's updated, and somebody says, "Hi guys."
Hello.
Woofty mufty guffty guff.
I predict YouTube comments will be off in under 10 minutes.
I don't know. I think
there'll
be some nice comments.
That'd be fine.
I probably should have got an overlay image as well.
Yeah.
Oh well.
We need like a maximum OBS.
Maximum OBS. So that's my waiting image.
Have you updated Fusion, Vic? Because I got an update this morning.
I did. I updated Fusion,
Oh,
so
okay.
Fusion is here.
Nobody wants to watch that.
So there you go.
Fabulous.
WhatsApp.
Have you used the Teams feature on it yet?
No, it'd be nice to do some sort of a collab.
Yeah, you can make like a Fusion team. I don't know if this is new.
Can I rename this? Can I rename this to me?
Oh no.
Oh no. Oh no.
Video capture device. Yes, video capture device. That's what I want. Preset. FaceTime camera. Okay. Hey. Why is it?
Yeah,
I'm so
sometimes
confused.
yeah.
I'm so confused.
You know, they like you kind of go and do the dry runs, right?
I know, but it was working before. Delete scene. Yeah. Okay. Scene. Okay. Stop. It doesn't matter. I'm just here as a bonus feature.
Oh, you went dark.
Yeah.
I could do this.
Oh, you get the YouTube link at the top in Zoom. That's quite neat.
Yeah.
Oh, we've got M7GIF and 20JNE watching us.
Very good.
Okay. Something appeared.
I'm gonna have it.
Something happened.
I'm really annoyed that this cup has this robin on this side, because I want people to see what's on my cup.
You just have to drink left-handed.
Yeah.
Where has that gone? Oh, I got it.
Yeah, so I think, Simon, I resliced that. I'm just gonna go off topic a bit.
Oh, reslice those.
Yeah,
those
I'm
gears.
gonna take this and
Are you printing them on like a raft?
no, you see, The problem is that what happened here is these are the beginning of the lines, and they're just in the wrong place. They go shortest. They're the shortest. Yeah, they're still here.
Can't use random or something.
Yeah, random. That's not very random, is it?
Not as these things go, no. What time is it? Oh, we've got a couple of minutes.
I don't know.
We got a few minutes.
Hi everyone, Sergey here, just Mark Zero Tango Lima November. I just with a question. Are we going to cover why Fusion 360 is better than SketchUp, or just something other tools, or we're just focusing straight on?
We're going to talk a bit about how and why and tools at the start. But if you want to talk about why Fusion 360 off better and worse, this is meant to be a conversation between all of us, so we can talk about that.
I would definitely suggest that, because it just many people has a kind of huge background of using SketchUp. So
yeah. I mean, and one of the things I was going to talk about is there's lots of ways to do it. I have a specific way I like to work that fits Fusion better than the other tools. That's not to say the other tools aren't useful. I mean, we'll talk a bit about mesh modeling and constructive solid geometry and stuff like that, because how you think about the problem probably determines which tool you find best. Aside from the usual religious wars, right? So
definitely.
I was going to talk about that at the start, but we'll talk as much or as little about that as people want.
Yeah, we have a rough plan here of what we're gonna cover.
If we talk for the next hour and a half, it's failure. If we all talk for the next hour and a half, it's success. So yeah, more than happy to cover anything anybody wants to talk about, really. Otherwise, it's me and Vic drawing stuff on a Thursday night, you know.
It's not very exciting at all.
No. So yeah, happy to dive into that. And equally, I'm hoping there's lots of people here who've got lots of other experiences, because I've used a couple of the tools, but not all of them. So if people are experts on Blender or something, I'd love to get their view, because I've never got my head around Blender. It just doesn't do it for me, and you know that left side of the brain thing just doesn't fire for me.
Fusion is what we know with Simon, and Fusion is what we sketch and extrude in.
I'm a failed engineer. Fusion's your failed engineer's tool of choice, right?
Yeah.
If in doubt, just pick another tool.
But there are other tools that are equally good.
I'll just post the link. We've got a few loiterers. We've got 8 people on YouTube, if you include me, Vic, and Robin. And Paul's watching. He isn't able to come. And Owen is here, but he's also here. I suspect half the viewers are us. No, John Mack, EI6, IZB.
Robin,
John is up the road that direction.
Awesome.
I could probably reach him on 10 milliwatts or something from here. Robin, I like your background.
You're live on YouTube, by the way.
Please do not swear. The question is, which of you is Davina?
Gonna wave to John. Hello, John.
Last orders, ladies and gentlemen, please.
A bit early for that.
Yeah, people are starting to appear, aren't they?
Yeah, I just did a tag on the server just so people were aware we were kicking off in a few minutes.
And the events just sent out a message to everyone. So,
and judging by the luck I've had this week, Vic, Autodesk are now about to reboot their servers.
Yeah. Oh, that would be amazing. I have a pencil somewhere.
I was trying to do a customer demo on Tuesday, and someone recycled our Citrix farm, and I'm just like, I had to fill for 15 minutes. Was not impressed. I may have said some harsh things down the chat channel.
Never.
Yeah.
You know me, mild mannered.
Quiet
Who
and
the-
unassuming.
Who the blink did that? I made another case, Vic, by the way, another one of those.
Yay.
That's my node in a case. And I got a right-angled USB mini to big USB-B, so I can plug it into my TNC.
Yep.
It's going to
I
sit
got the
back to back
same.
like that.
It's in the project box somewhere.
I have an OARC. No, it's over there. I have an OARC. Good times. I think I do. I should do.
You do. We can see it.
Awesome.
I've got some whiskey.
I need some scent.
You might think it's in the wrong corner, but it's in the right corner.
It's not
in
doing
this
a good
corner.
job of tidying up what the dog has made a mess of.
That's right. I'm just grateful for the really overexposed, messy corner.
Good evening, all.
Evening.
Good evening.
All right, we're going to give everybody a couple of minutes because they're slowly assembling.
Find a better logo. Let's see.
The best one is off the clothing stuff. That's the one I used.
I've been working on all the
overexposed
branding stuff.
Well, someone is on YouTube very behind there.
Oh, yeah, YouTube's laggy AF.
Well, it's meant to be a minute behind so that we can.
Yeah.
We can. If someone says something embarrassing, we can watch it again.
Yeah.
They learned from the.
Way.
It's a SpaceX approach, right?
There's the sapphire. Oh, there we go. Let's add the.
I think I'm gonna move you here. I'm gonna move you over here. Here we go.
And you're broadcasting to YouTube, right, Francis?
Zoom is. So
Yeah.
it's not me as such. It's just the server who's watching. So whatever you do in terms of hosts, it'll reflect on YouTube, and I'll be watching it just in case.
Okay, I'm trying to work out how we pin Vic.
Just pin him.
It should just work.
Just pin him, and he'll get pinned, and everyone can enjoy. I think we're getting, well, just after time. I think we've got most of the people.
Well, I think I'll just mute myself. Bye for now.
Cool.
That's unusual for Robin to just sit and enjoy.
You'll unmute in a minute, don't
I'm
you?
back. I couldn't wait.
He didn't stay muted for long, did he?
Shall we make a start?
I think so.
Okay. So by way of introduction, welcome everybody. This is the first time we've done it in this format. So we're streaming live on YouTube. So hello YouTube, as well as to OARC members who are on Discord via Zoom. We'll take comments however they come. So if you're on YouTube, feel free to put a comment in YouTube, and we've got people watching, and we'll highlight the comments. Equally, if you want to just shout out into Zoom, that's fine. Or if you want to put your hand up and use the chat feature. Vic and I we've got enough material to talk for an hour and a half, but if we talk for an hour and a half, it's failure. We want this to be a conversation, and we've styled this as a conversation. Vic and I aren't experts. We just make bits of stuff, and we like to share what we do, and we find this process is helpful for us to learn. So we reflect on our failures and the occasional success. And we know there's a lot of expertise inside OARC and outside, and we'd really like you as part of this. So we'll talk a bit about our process, and we'll show you how we do it. But I'd absolutely love it if people would interject, ask questions, tell us of a better way, because that will make this go much quicker. I think, as we always say, there are genuinely no stupid questions here. We're all stumbling around in the dark to some extent. We've found a few things that work and a few ways that work, and a particular way of using the tooling. And I think Sergey was talking, are we going to talk about tools? We absolutely are. So what we aim to do over the next kind of hour, 90 minutes, however long this runs, is talk you through our process for making something. Vic, do you want to show them what we're going to make?
Yeah, sure.
Have you got one?
So how this conversation started with Simon, and hello everybody, by the way. So I just, you may be familiar with the printables, you may be familiar with the Thingiverse. So I found this and I was like, that's a really cool design, right? The only problem with this design is that it's a kind of one size, and you either take it or leave it. You can't really do anything with it. It is what it is. You just download this model and you have it, and it ends up for the choke. The nice thing about this model is that it has these grooves here that you can just thread the zip ties through, because if you ever made one of those, I'm gonna just switch the view a little bit. So if you ever made one of those things, you know that you're gonna wrap the coax around it, and to hold the zip ties, you're gonna put the sellotape on it, and then you're gonna wrap the coax, and then you realize that you did something wrong, and then you will try to pull those zip ties out of it, and you eventually will. But then you really realize then that you fixed whatever you did wrong, and now you have to push them back in, and that's not going to happen. So you have to unwrap the whole thing and then do it again. So the design that we have here is quite nice, because that allows you to kind of make that mistake and then go again if you need to. But it's just one size, right? So the description says here 40 mil tube, okay. But what about if I need 50 or 35 or something like this? So that's how the idea was born. And then we said, why don't we just design something that is parameterized, so we can make it whatever size we want. And then the next idea was, why don't we just show people how to do it? And here we are. So that's what this night is about. We're going to be making this.
Yeah. So as Vic said, we're going to try and make a parametric version of that. Mostly because I keep convincing Vic that parameterized models are the best thing ever. So I wanted to kind of demonstrate how you can do that, in this case in Fusion 360. And this is probably the place to talk about tools. So the approach I take, because I was trained once a very long time ago as an engineer. So in my head, the start of all of my processes is a sketch. And a sketch isn't, and this is something in 3D printing in the Discord server we've been talking a bit about. People say, oh, I can't draw, so I can't do 3D printing. This isn't about drawing. This is not about representation. You know, the goal here isn't to recreate this object as a piece of art. The job is to find its essential features and to create a model that has those features, and then build something that works the same as this, right? So there's a guy called George Box who once said, all models are wrong, some models are useful. And it's my mantra, right? So my goal is not to recreate the thing that Vic's seen. It's to look at it, put my engineering hat on, figure out what are the features of it that make it what it is, make it a former, and then we're going to sketch that, and we're going to use that sketch as the basis of our design. So I take a really reductionist view of this. I'm trying to make the least number of features I can to give Vic the piece of functionality he wants. That suits Fusion 360, because Fusion 360 is effectively an old school CAD package dressed up as a 3D modeler. So it lets you effectively do 2D sketches and then create 3D objects for them. Fusion does much more than that, though. So there's other ways to do these things. People would have seen tools like OpenSCAD. So OpenSCAD uses something called constructive solid geometry. You make everything out of primitives. So you use spheres and squares and rectangles and prisms and whatever else, and you mash them together, and you happen to do it in code. You can do that in 360 as well. You can actually just take primitives and connect them together. And people who come from a more sculpting or 3D modeling background use tools like Blender or Mesh Mixer, which are all around meshes. So looking at the outside of something, so take my water bottle, I would model this as a cylinder with a height and a diameter. In something like Blender, you'd actually create something and you'd stretch it out, and you'd have a circular mesh that you'd extend, and you're manipulating the surface. They're all valid approaches, and they all have their strengths and weaknesses when it comes to making particular objects. So I've only chosen this route because it suits what I'm trying to do. There are definitely other ways to do it, and if people have used other tools and can think of other ways to do this, please pipe up. Because
interesting comment in the chat. Interesting time. And Robert Putt just said, everything I design for 3D printing always looks ugly. I forget how thin plastic can be, and everything looks very chunky.
And that's kind of if I was going to look at the weaknesses of the approaches, people who use Blender and mesh-based tools tend to make much more organic and prettier things because the method lends itself to it. My method lends to very reductionist, angular, ugly, thin things. So yeah, there's a bit of that kind of comes through. Stu's got his hand up.
Just if you're just doing the one thing I found is if you're just doing a quick resize, then Tinkercad's really good for that. Because it's online, you don't need any software installed, and you could just resize it really quickly.
Yeah, and for super simple jobs, you can. I mean, it's one of the things we could show in this. You can directly manipulate STLs. It's not always fun. So we did a bit when we were building the TNC cases. If you get a complex STL, manipulating it directly can be an absolute nightmare because there's so many surfaces and facets. But yeah, things like Tinkercad, FreeCAD, if you just want to change the size of something. It's interesting how good slicers are getting now as well. So you could actually just take that model and shove it into Prusa Slicer or Cura and change the height. You know, you just scale it in one dimension, but there's limits to how far you can go with that.
Comment from Robert in terms of software. He says he uses Autodesk Inventor because work pay for a license.
That's nice bit of kit. Yeah,
but if he didn't, he'd probably use SketchUp.
And a lot of people do use SketchUp's probably, it was the tool I used before I got hooked on 360, because SketchUp was bought by Google. I can't remember who used to do it, but that can be quite good as well, particularly if you want to do shall we call it prettier models, because you can overlay graphics and stuff. You can do some quite nice things with SketchUp. Okay, so what we're going to do
is final comment.
Yeah, go for it.
Quickly throw in. Theodore was just also saying, is it worth mentioning the difference between the license limitations and what you can and can't do with various bits of software, and which one you would use for what?
Oh, we're amongst friends, aren't we? If anyone from Autodesk is watching, I love you and I love your product, but your licensing model is garbage. So Fusion 360 is free for hobbyist use and free up to a certain amount of revenue. But what they mean by free has changed. So the current limitation in Fusion is you can only have 10 documents editable. So if you look on Vic's screen, does yours say 1 of 10, Vic? Top right.
It does 7 of 10.
Yeah, so it's 7 of 10. So at any one time, you can only have 10 of your documents editable. And you don't lose anything, but it's just an irritating annoyance to remind you don't own this product. It's worth saying, though, Fusion is an application streaming service. So effectively, the client you get on your desktop just reads all the graphics commands of a bunch of compute at the far end, which means it's always live. You know, you never have to update much beyond it does update itself quite a lot. But yeah, there are some limitations, particularly if everyone doing anything commercial with 360. As soon as you start generating revenue, you can't use your license. There are things like Tinkercad, FreeCAD that are pretty much free. Is Tinkercad free but not open source? Someone will correct me.
There'll be a minute delay on YouTube.
Yeah, there'll be a minute delay on YouTube. I know tools like Blender are pretty much free. Mesh Mixer, which used to be an Autodesk product that used to live outside of 360, has been mashed inside of 360 now. So yeah, I mean, in terms of which tool's best, I'll leave it for others to comment. I mean, I use 360 because, notwithstanding the license limitations, I just find it incredibly useful, and I'm too old to learn anything else, if I'm entirely honest. I'd love to learn Blender because the things people can make in Blender are really interesting, and I've never had the skill for it. So what we're going to do is we're going to do a parametric sketch to kind of address this, and we'll do a little bit of feature manipulation in 360, and then we'll kind of iterate through. So the plan is to kind of do a really simple initial design, then do bring some parameters into it, and then we might end up doing my fancy thing I figured out how to do this afternoon around rotating features. So the heart of every 360 drawing is a sketch. Now you could, again, approaches, you could just start putting cylinders on the page and extruding things and going at it, but that's not the way we're going to operate. We're going to start with a sketch. So top left, Vic,
sorry,
create sketch.
just a quick interruption there.
Yeah.
Paul, Mike 02TZO says, Tinkercad is a free of charge online 3D modeling program that runs in a web browser.
But is it open source, Paul, was my question. I know it's free, but I couldn't remember. I know one of them is open source, and I can't remember which one it is. So we're going to start with a sketch. So Vic's going to click create sketch. The first thing you've got to decide is what you're going to sketch on. So by default, there are two things you can sketch on. You can sketch on a plane, the XY, the YZ, or the ZY plane, and that's what it's asking you here. Or you can sketch on any flat surface you've already created, and we'll come to that later. So we're going to sketch on the XY plane. And now you've got effectively a 2D environment, but it's really a 3D environment. But we're going to draw in 2D first. So what we're going to do, Vic, is we're going to draw a circle. Again, there's lots of circles you can draw. We're going to draw what's called a center diameter circle. So Vic's going to go to the origin, and then he's going to drag it out. And we're going to make it 50, Vic. And we're going to make it 50 millimeters. So at this point, we're going to hard code our dimensions in. We'll come to parameters in a minute. The second choice we're going to make is the wall thickness. So I think we're going to go for a 5 mil wall, Vic.
Yeah, sure.
So again, a number of ways we could do this. We could offset that circle 5 mil. We could draw another circle 45 mil. We could draw a circle that's 50 minus 5 mil. But we're going to be clever. We're going to draw a circle, Vic, which is going to be 50 minus 5 mil. And we're going to explicitly put it in there as a calculation.
Cool.
So anytime you can put a dimension in, you can type an expression. So you could just type 45, but we can also type 50 minus 5.
Yeah,
We'll
Simon, sorry, got another comment
Yeah,
from
go for
Paul.
it.
Yeah, Tinkercad is
It's
proprietary,
proprietary,
free
yeah.
of charge software, so not open source.
Yeah, there is. If people love open source, there is an open source one out there, which I'll try and remember. Okay, so we've done that. You'll see two things have happened at this point. You'll see that the enclosed space has gone like a sort of grey-blue. So that means that it's recognised effectively as a surface, as a continuous surface, and we'll see why that matters when we come to extrude.
I think it's worth mentioning as well that sometimes when you draw in Fusion, the most important thing is actually aim your cursor, because Fusion will try to be helpful, and it will try to drag your cursor in some places that you don't necessarily want this. No.
It's probably worth talking about snaps, grids, and constraints.
Yeah.
So if you've ever used a CAD package, you'll understand the concept of snap. So if you go near the intersection of two lines, AutoCAD will effectively snap to the intersection. So if you don't want it, you've kind of got to override it. You can tell something to intersect. So there's a thing called constraints. So if you look on the right in the sketch palette, there's a whole load of things that you can say, these things are coincident, they're collinear, they're perpendicular, they're tangents to each other. So you can kind of tell it what the geometry should be. But you can also have a grid, and you'll see a grid on the screen. But as you zoom in, if you zoom in, Vic, you'll see the grid will refine. So it will also kind of try and help you and snap to the grid. And you can set that as a hard snap. So down bottom center, Vic, see you've got a number of tools at the bottom. Yeah. One of them is grids, and I can't remember which one it is. You can turn the grids on and off. You can turn the snap on and off. If you want to run in imperial units, for instance, you can make the grid 0.1 inches rather than, I think the default is 5 millimeters. You've got lots of control if you want to draw very precise things.
Simon, sorry, mate, just a quickie.
Yeah.
Paul Atkinson comes in with a comment. He's got FreeCAD is open source alternative.
I knew there was one.
FreeCAD.
Apparently, Theodore has also commented on SCAD as being an open source and parametric CAD, whatever.
Yeah, OpenSCAD. Yeah, OpenSCAD is again, a lot of parametric models are done in OpenSCAD because it's like code with variables.
Yeah,
and you'll see
Paul's
some
come in as well with Blender, FreeCAD, LibreCAD, and OpenSCAD
Yeah.
are all free open source.
Yeah, yeah. Thanks for that. So at this point, we've kind of done the geometry of the former. So we've got a couple of choices at this point. We can finish the sketch, which is what we're going to do. Yeah, and you can click it up the top, or you can click on the right hand side. Someone's got YouTube playing. So what we can do now is we can extrude up our former. Someone needs to go into mute, I think. Whoever that was.
So I was just about, it's funny how Simon and I work together, because I was just about to say that we are nearly finished. That we are,
yeah.
so after drawing this, you could potentially just say, that's my former, I'm just gonna do what we do next, and I'm done. So that will be your most basic model. And if you wanted to change these dimensions then on the sketch, you could just go and edit this sketch and just change these dimensions then. And even after extruding, I think you could just do that.
Well, that's we should show that, Vic, because that's the clever stuff.
Yeah.
The thing to remember, that if you look down at the bottom, in the bottom left, there's some transport controls and there's a timeline forming. So every time you do an operation in Fusion 360, they're all applied in order, and you can effectively think of it as like a timeline, and you can go back in time and change something and it will ripple forward like an episode of Star Trek. And you can break the timeline, and we probably will break the timeline at some point. So we'll show you the timeline feature as well, because it gets interesting when you come to do parameters. And as Vic is doing, always be saving.
Yeah, I'm just gonna save it just in case something.
Yeah. So next operation, there's a couple of choices. We could make a cylinder and we could cut the center out. Actually, it's easier just to extrude that there. So you'll also see as you click, because it knows that's an enclosed surface, it will let you select it just by clicking, which is a nice feature. It's also a sign you've done it right. If you're trying to click something in your sketch and it won't select in this way, it means your geometry is not quite right. You know, you haven't joined something up, or an intersection hasn't worked. So it should be intuitive as to what you click when you've drawn your sketch.
Also, it's worth reminding people that this happens after you save your sketch, right? So that won't probably look like this if you didn't save your sketch. So if you're at this point, you're watching this back, and you're at this point and you're clicking these and they are not showing like that, it's probably because you didn't save your sketch.
Yeah, exactly. So we're going to do extrude. What we'll do is we'll extrude that outer surface, Vic. So a couple of ways to do it. You can hit E, you can hit the extrude tool. We'll hit the extrude tool. It's pre-selected our surface because we'd selected it when we went in. So if you have a look at the screen, it's got one feature already selected. We could select more. And now we could drag the arrow up the 50 mil. We could type a value in. We could put an expression in. We can do whatever we want. How high are we going to make it, Vic?
15 centimeters, maybe.
Yeah, go 50. Okay.
Oh,
Put it in. You'll see at the bottom, there's a bunch of choices. It says new body. Because this is the first thing we've created, you only really got the choice to do a new body, but we'll look at cuts and things in a minute. So that's going to create a new body. We're going to say OK.
Just to comment, sorry, good. Simon, when you're talking, we don't see the screen.
We need to pin.
We need to
Yeah,
pin the...
oh, okay. I don't know why the pin's fallen off. Apologies. It shouldn't have fallen off. It was there.
Yeah, it should stay on Vic.
Oh, there we go.
You can manually pin Vic as well, which is what I suggest you do.
I'll be like a butterfly. Pin down.
Pin to the wheel.
Yeah.
Is that
Anyway.
better?
Yeah.
So we're going to say, OK, we're going to get a new body. Couple of things to notice at this point. So down in the bottom left, we have another thing in our timeline, which is the extrude. If you right click that, Vic, you've got the option to edit it. So you can, at any point in time, go back and edit a step you've gone in the process. So we can go back and we can edit that. We can equally go further back in the timeline and edit the sketch. And we'll come to that in a minute. Other thing to look at, in the top left, in the hierarchy of the build, if you like, there's now a thing called bodies being created. If If we expand that out, we'll now see our bodies there. If we want to, we can hide it. We can rename it. And I suggest you always name your bodies. So I would rename that former, because when we save it out as an STL file, that'll be its name. But also, as you're creating and cutting things, it's a good practice to name your objects. And also, when you turn off the visibility of a body, you can change what happens. So if you're cutting things and you only want to cut one body and not another body, if you hide the one you don't want to cut, you can effectively cut without damaging it, which can be quite handy.
I'm just gonna do something here. I'm just gonna go and edit that sketch. So we are back to the sketch. So this is just because of the pin. But I'm just gonna go back here. So what we did there, we just saved this sketch, which I can do now. There you go. And we should have extracted this. And to extract this, we can actually can we go back in time? We can go back in time.
Yeah, if you drag the cursor.
Yeah.
There you go. So that's like we haven't performed it. So the extrude's in there and we can roll it back. Well, we've rolled back to before the extrude.
Yeah, we can also, this is the selection I was talking about for that. If this doesn't happen, it's probably because you didn't save the sketch. But anyway, we're gonna go forward in time.
Now, what we can do, we can actually go back to that sketch and edit the sketch. And what will happen, because of where we are in the timeline, it will update our extrusion. So let's make it, are we going to make it bigger, Vic, or are we going to make the wall wider? Chef's choice.
We'll just make it bigger. Why not?
Okay. So again, you can go back into a sketch, you can double click a dimension and you can change its value. Now what will happen is this will now roll through everything in the timeline. So when he clicks finish sketch, it will now commit that change to the timeline. So what we should see is that our extrusion has automatically got bigger. Now we could have edited it and changed it any other way, but because you've got that timeline concept, you can go back and change things and see their impact. So the next thing we've got to do, Vic, is we've got to put those tie wrap grooves in.
Yeah.
So there's a couple of ways we could do it. We could edit this cylinder, so we could effectively cut the cylinder. We could go back into the sketch and make the cut in the sketch and create another piece of geometry that would effectively cut. So I think let's do the edit sketch, Vic.
Yeah.
So we'll edit the sketch.
Do you want to do it from here? There's another way to do that, right? I can click here. Oh,
yeah, you click in the you click in the tool in the structure as well. Yeah, or you could create a new sketch is the other way you can do it.
You could do that. Right.
We're going to edit sketch. So what we want to do is we want to create effectively, we want to cut a piece of the circle off. There's a couple of ways to do it. I had a bit of a practice this. I think the simplest way is to draw a line from the center out almost to the edge, but leave it short the depth of your tie wrap. And looking up your tie wraps, Vic, I think your tie wraps are 0.8.
0.8 mil. We can do it one. We can make a 1 mil. Why
yeah,
not?
make it 1 mil because it makes no odds, right? So I would draw a line. So go to the line tool, go to the center, and again make sure it snaps over the center point. That's it. And then I'd drag it out. Make sure you drag it so make sure the angle is consistent. And then I'd type in whatever it is.
60, 59, right? Yeah. Oh, it's not 59.
Half because we're doing a radius, not a diameter.
Yeah, exactly.
There you go.
Where did 59 come from?
Well, it's going to be half in 50.
It didn't.
No, I just mean generally, where did 20?
Oh, sorry. So I was going to show you my finger, but it doesn't work like that. So you see the dimension here. It's 60. So from this arrow to this arrow, so the diameter of the circle, the outer circle, is 60. But we want to align that is half of it minus 1. So that's 29.
So we're going to cut a 1 mil off. So if you pick that point, Vic.
Yeah.
And then what you should do is go to the end of that line and click the line tool again.
Yep. So Francis, you understand, right?
Yeah.
Yeah. Okay.
Okay. So pick the line tool again, Vic.
Mm-hmm.
and go from the end of the line and then drag it up until you intersect the circle. There you go. See, it does this. Now, if you hold it in the right spot, it will snap on the circle. See, it'll go to a cross. There you go. Click there. And that's the intersection of that line and that circle. And then zoom back out. And then go from the line down again to the other piece. Now, you'll have to click the end of the line again.
Yeah. Here.
That's it. And then go to there. And it will, again, it will snap.
Yeah,
That's
so
it.
Kind of snaps here.
That's it there. And it should snap. There you go. And then hit escape. So what we've done is we've created a little bit of geometry there that we can use to cut our extrusion. So if we go finish sketch, Vic.
Just I'm going to point out these little
The constraint icons, yeah.
little strange icons here. So if you look at your constraints here, you will see that they are kind of similar, and this indicate what Fusion automatically assumed to be the constraint for these lines, right? So they have to be perpendicular, and then they have to be. I don't know what that constraint is actually.
If you hit the constraint
Horizontal,
drop down, it will show
vertical.
you them all. Hit the drop down, Vic, in the ribbon.
Yeah. Oh,
There you go.
here. There you go. So that's what these weird kind of looking icons that you didn't put here are. Anyway, let's go.
But you can change those. So if you don't want it to be 90 degrees, you can turn it off, and then you've got freedom.
Yep.
So now we have two ways we can create this feature. We could edit the extrude and cut that piece out and not cut it. Or we could do a second extrude, and we'll do a second extrude because it's quite interesting. So Vic, if you click that region we've created.
Yes.
Because
Because I need to do something else. I need to.
Yeah, hide it and click. Yeah, that's it. Because it thinks you're trying to click the top surface.
So what I did there is I just made the body disappear. And what you see here, that halo here is actually the top of the body. So if I bring the body back, there you go. So that's what it is. I'm just going to click out of it, and then halo is gone. So I'm going to go here. I'm going to find this.
There you go. And then we're going to do extrude. But this time, what we're going to do, you need to bring the body back as well, Vic, so it knows it can cut. There you go. Remember we said earlier, if you hide a body, it isn't affected. So if you drag that up now, Vic,
so
you'll have three choices.
So when we are here, I'm just going to talk about a little bit about the controls. So most of the controls in Fusion are done through this little cube here. And if you ever get lost, you just click home and you come back to this position. And then I'm just gonna kind of drag it in such a way that I can see what I'm doing the best, which is maybe here, and maybe I want to have it next to this window. So that's what I want to do. I probably want to see the top of it as well. The middle button click does this, so you can actually position this. There you go. So now you're gonna do this extrusion.
It's probably worth saying as well, if you're not steady on the mouse and you're not sure, the other thing you can do, see where it says orientation one side, and then the next one down says distance. If you change distance, you can do to object. And if you now click the top surface of the cylinder, it will automatically figure out how tall that is. So if you're not steady on the mouse and you don't want to do it, and you know there's a bit of geometry that you want to make it work to, you can use that. So you'll see, because we're overlapping something, its assumption is that you want to cut. Now we do want to cut, but if you just click where it says cut, Vic, you've got three choices. You can cut, you can join, or you can create a new body, or something called a new component, or leave components. So you could create another piece there, but we do want to cut. So if we say cut, it will cut it away. And that's done our tie wrap bit. Now, do you want to see the clever bit I learned today, Vic? That negative space we can use as it's what's called a feature. So because we did a second extrude, that extrude is what's called a feature. We can use that as part of a pattern. So we want 4 of those, don't we, Vic? We want 1 at each, each of the cardinal directions. So we can do something called a circular pattern. So if you go to the create menu and do pattern, circular pattern. There you go, circular pattern. At the moment, it says object type, and it probably says bodies. You can also do something called a feature, and a feature is anything in the timeline. So if we say feature and you click, you could click in the timeline, but you can actually click it on the body, Vic. No, click that. That will count as a feature. It now wants to know what axis do you want to do it around. So if you click that and just rotate, because you want the vertical axis. So you'll need to rotate the model so you can see it. No, that's it. And then you want that blue line going up.
Oh yeah, you want.
Because that's the axis you're going to rotate around. So hide the body is probably the simplest thing.
Yeah.
Because the origin's buried inside your object.
Yeah. So these are the axes here.
Yeah. And click the blue axis.
So these are the axes around which we're going to rotate.
Yeah.
There you go.
And then bring the body back. And then you can do 2, 3, 4, 5, how many of those you want. And then say, okay. And it's now created 4 equally spaced cuts for your tie wrap to sit in. That's the bit, Vic, I figured out this afternoon.
Very cool. So whenever you have something that will repeat around a certain circle or rectangle or whatever, you probably want to use some sort of a pattern, because it will place it, where you want this to be. So patterns are, there's a rectangular pattern here, and there, when you Fusion has this nice thing about that all of these menus are explained in some way, so you can actually have a quick look and just read, what you want. And for something like this, that would be the way to do it, just to draw it and then repeat it effectively around, but let Fusion do the lifting. Cool. So we are nearly there.
So at that point, we've effectively created our first cut of it. If you wanted now to create an STL, if you go to the body in the hierarchy and right-click it, our former, you can do save as mesh. And you've got a bunch of choices now. You can save it as an STL, which is kind of the default format. I prefer to do 3MF, which is a slightly better object format than STL, mostly because it has more information. So STL is just the raw mesh. 3MF is a better format, and most of the slices will read it. You can also tell it effectively how to tessellate this. So do you want it in millimeters or inches? Always and everywhere you want it in millimeters. Everybody's printer runs in millimeters. You'll get big scale problems. You can change the refinement. So effectively, how many triangles does it use? And you can do high, medium, low. High's normally fine. You're not creating millions of things. And if you want to, you can just create the file, but you can, if you're clever, send it straight to your 3D print slicer.
So if I click now, it will just save it somewhere in the drive of the computer, but I have something like this, and mine is actually custom. I had it a different way, but I installed new Cura, and I just needed to point it to my slicer, so it tells me what application it is here, and we can just say hello. So it will do its thinking. Oh, look at this.
And this is quite good. This kind of workflow is quite neat. I'm glad they added this.
Oh, and it's actually open on another screen.
Yeah, it's on another screen. And then you're in your slicer, and you can kind of set all your slicer settings and run off to your heart's content.
Yeah. So I would just slice. Ooh. It's a vertical. It's that Z axis that is kind of.
You've got one. That's the point.
Yeah, and I have very thin layers. But anyway.
Yeah. So that's kind of the basic walkthrough. What we're going to do now is we're going to put some parameters in, and I think we've built this model such that it's really easy to add the parameters, and then we can play tunes on it. So how do you create parameters in Fusion? Basically, they're built in under the modify menu. You will see if you go down to change parameters.
Yep.
There's a whole bunch of them. So you'll get this dialog box called change parameters, and there's a couple of interesting bits in there. If you expand the former out, all the things in the timeline. So remember the timeline in the bottom right, they're all there, and it tells you all the measurements you've put in. So they're already there. It's secretly behind the scenes. Everything's a parameter to it.
So
And you can expand out and you can look at the extrude.
I'm gonna just do something here. I'm just gonna go to, oops.
Now you're
Oh,
gonna
I
have to
can't.
close that dialogue, I
I have
think.
to close that
Yeah.
dialog. Okay, that's fine. I'm just gonna go to this. So you see all of these measurements here. Let me just blow it up a little bit. So if I go to my
Yeah,
what is
still
it
in
again?
modify.
Modify, yeah.
There you go.
Yeah, there you go. So all of these somehow correspond to what we did here. So you have a you have a diameter dimension 2, 3, the linear dimension, which is this dimension here. So you can change all of this here if you wanted to.
Yeah, you can go and you can change values. But the clever thing is that you can add your own variables, your own user parameters. So at the top, there's a little button called plus user parameter. So we're going to hit it, and we're going to. So what we'll do is we'll do outside diameter. And if we want to, we can give it a value right now. Did we say 60?
Yeah.
Yeah. So we put 60 in. We can put a comment. So in about 3 weeks' time, we understand what the heck this was. So this is the external diameter of the former. Always comment your parameters. Ask me why. And at this point, this won't do anything with it, but it's now something we can use, and I'll show you how we use it. The other one to do, Vic, so do user parameter again and do wall thickness. Now, the question may come in, how do you know which parameters to do? The simple answer is I built this because I knew what the parameters were. It can be anything you think changes this. The trick is not to over constrain your model, as you will see. And I think we did 10 or 5, I can't remember. It doesn't matter because we'll fix it in a second. And this is the thickness of the walls on the former. And then we'll add height. So plus user parameter, and we'll do height. And we did we do 150? I can't remember what you did. Yeah.
Yeah, let's do that.
And then we need 2 more. We need the number of tie wraps. So tie wrap number, whatever you want to call it. And we're going to use that to drive that circular pattern. So, you know, we put 3, 4, or 5 in. We're going to use that. And with a bit of luck, this will work. So put 4 in for now, I think, Vic.
Ooh.
Make it unit, not millimeter, probably.
Yeah, no units.
Yeah, because this is a quantity, not a dimension. It sort of doesn't matter, by the way. It will understand if you tell it 4 millimeters, it'll work it out. But it's better to pick it right. Steve says, is it just me or is Vic's going out of focus? It may be the res of what Vic's doing is a bit blurry.
Yeah, it's just the straight at the OBS.
Yeah.
The problem with using OBS like this, it struggles with live screen, but you can get the idea of where he's gone and what he's clicked, but it does make looking at detail kind of pointless.
Yeah, and the last one you need, Vic, is tie wrap depth.
Zip tie. Oh, I think I didn't like the. Oh.
Paul says we've been chatting about it. Screen share would be better. In what sense, Paul? Is there a better way we can configure it inside?
Yeah, so on if instead of it's one for next time, but basically rather than using OBS like this, actually
do a screen share. Yeah.
However, that would make YouTube a little bit dull because we'd just be looking purely at.
That's true.
An image. We'll find a way.
Tie wrap depth, Vic, is the other one you want.
So what am I doing?
Tie wrap depth. Yeah, because on a screen like this, it doesn't really help. Or we tweak Vic's OBS settings.
I've never seen a good OBS stream that's compared to screen share on Zoom, because
So
it's as much Zoom.
Yeah, there's a couple of ways we can apply the parameters. We can do it in this box. So we could go through all the measurements in the box down here and put the parameters in. But it's easier actually to go into the sketch and do it because it's more intuitive. So if you say OK, Vic, or close or whatever it is.
You know what I'm gonna actually do, because my
His OCD's
ODC,
kicked in.
my ODC. Name your variables.
Yeah. So if you do the major diameter, the former diameter, and double click it. No, the measurement.
Oh yeah.
So remember we said we can type a value, we can type an expression, we can actually type a variable name. So if you delete that out, Vic, and type diameter, you'll get a little box pop up that says, oh, you have a variable.
Oh.
Would you like to use it? Click it. It now puts that in the box. See, it says f of x. Just hit return. So previously, it just had the value and the diameter. Now it says f of x, diameter 60. So that means it's set to a variable now. So that's how you know you've set a variable as opposed to, doing it by measurement.
So I'm just gonna show people again.
Yeah.
So I think the panels. So we had it like this.
Yeah. So you don't get the f of x sign.
And we have this.
Yeah.
And then we have this.
Now, the interesting one is that inner diameter is actually a combination of two. So we're going to have to write an expression.
Mm-hmm.
Oh, are you going to change it and show?
Yeah, I'm
Do
just
it,
gonna.
do it.
Let's go for 50 and see what happens if we break the model. Oh, warning! What is the warning? Compute failed. Oh no!
You've got to save the sketch.
Yeah. Go. Oh, it actually did do something. Value that was 60. Okay.
Yeah, I think it was 60 for now. So the second one you're going to do is that inner diameter.
Yeah, this one.
Yeah, so that one. Now, if you remember, we typed that as an expression.
Mm-hmm.
So actually now you're going to do outer diameter minus wall thickness. So you can operate on parameters just like any value. So you can compute it. And what we've done is said it's that distance is the outer diameter minus the thickness of the walls. It's probably twice the thickness of the wall, Vic. Because remember, that's a diameter, not a radius.
Yeah.
So if you double click it, you want minus twice the wall thickness.
How do I go back to the
Hit escape.
function?
Hit escape. Double click. There you go. Now pick that's it. Put brackets around it and do ×2.
Times 2 here, right?
No, not the diameter. It's the diameter minus twice the wall thickness.
Ah, okay.
If you think about it, you've got a wall on each side.
As it was asterisk, right?
Yeah. That's it. Did you bracket? No, the bracket. It's brackets around the wall thickness. That's right.
Yeah.
Yeah.
Like in the Excel.
Exactly. Just say that.
What did you do?
I couldn't read your expression. What was your expression?
Just something minus.
Oh, you made the wall thickness 10. That's why. No, that's fine. It'll come out when we make it 5.
Okay.
Now the tricky one is now this length, the length to the feature. So if you think about it, this is the wall thickness minus the tie wrap depth. Sorry, not the wall thickness. This is the outside diameter divided by 2 because you want the radius minus the tie wrap depth.
Yeah.
That's the expression.
So we can just do this.
Yeah.
Say it to me again.
Open brackets. the diameter. So is it called out? So that's it. Divided by 2 to get a radius. Close bracket. Minus tie wrap depth.
I've been wondering whether it would have been easier to make the circles 2 radius and everything else being the variables, the radius, and made the everything else 2 times it.
So you can, but drawing radius circles is annoying.
Fair enough. That's good.
You can, so because we did center diameter, you get that. You can do a radius circle. Vic, do us a favor. In the create menu, give me the drop down, and then over circle, show me the 3 options. So you can do center diameter, which we did. You can do a 2 point. What's the middle one?
3 point.
2 tangent, 3 tangent.
Yeah, 3 tangent. Yeah.
You can't do a center radius, which is just annoying.
So you're either going to have to set the circle to be twice a radial variable.
Yeah, you could have a radial parameter and then make the dimension twice the radius.
Yeah.
It's a peculiarity. I don't know why they don't do it.
That would make so much more sense.
Yeah, but then you'd get all the Tau people telling you that center radius is wrong.
Maybe that's it. Maybe it's a Tau conspiracy.
It is. I think the reality is most people measure the diameter. You usually measure the diameter, and because it comes from an engineering background, that's why they do it.
I guess that's
Okay.
also a valid reason.
So, Vic, if you now finish your sketch,
Oh, excellent.
nothing should have changed.
Exactly.
The other one, there's now 2 things we need to change. So we need to change in the first extrude. We want to go right click edit feature. And now we want that height parameter, so that height value, which is to object, to be height. That's it.
Oh,
Now, what should happen is the cut should have extended. So you remember, if you edit the second extrude, you'll remember we did to object. So that will automatically pick the height up because we said do it to the top surface. So I don't need to make this height. It is height because the cylinder's height. So again, don't make everything a parameter if it doesn't need to be. Use things like extrude to the top surface. And then when you change one parameter, everything will follow. Mostly because what you'll do is you'll mistype your parameter and then you'll wonder why it's broken. So if you cancel out of that one, Vic, because that one's fine. And then the last one is we're going to change the circular one. So go to that final feature, do edit. And now all we need to change on this one is our quantity becomes whatever did you do tie wrap number?
oh, count.
Count. There you go.
And there you go.
And say okay.
Zip tie. Yeah.
So you should now be able to go into parameters and make it 6 zip ties, and it should just seamlessly work. So sort of drag it out the way so we can see. And then say okay.
So, yeah.
Click off it. Yeah, there you go.
Yeah.
There you go.
Oh,
Magic. And you can make it shorter, so drag it down to 100. And it should seamlessly change. Oh, magic.
bomb.
And you can change the wall thickness, and you can manipulate all of those parameters now from that window. What I wish you could do at this point is save parameter sets. So I'd like to be able to go, here's a 50 mil, a 60 mil, a 70 mil, but you can't seem to save parameter sets. So if you're listening Autodesk, that's a feature I'd like. So we've now made a constrained parametric model. You can still break it. So if you make the wall thickness negative, you will break it. But you would expect that to break, right? There shouldn't be a standard value you can put in here that will break it.
Oh, you didn't break it. You just made it funny.
It's not hollow anymore. So there are limits to what you can do. But we've set it so there's an intrinsic logic. A negative value for wall thickness is clearly nonsense. So if you put any realistic value in, it should still operate, if you see what I mean.
Oh, you could, yeah. Where's the depth? Yeah, okay. Because you could break it like that, I think. Yeah.
Yeah, if you put yeah, exactly. So you can put some stupid values in and break it, but by and large, that should stand up to anything you really want to do. You know, you could put a silly number of tie wraps in, and it would just cut everywhere.
A passing comment by Robert on YouTube that I'll heavily moderate, but there was an interesting comment, suffice to say, that you can, it's always worth bearing in mind, you can 3D print things and use them as a basis for a mold.
Yeah,
So
no, that's
Yes.
we were talking about this the other day. Yeah, a lot of people use silicon and other things and create
yeah,
kind
you
of
can see where he was going.
yeah. Yeah, no,
But-
that's a really good point. That's a really good point. I mean, there
But
is
if there was any concern about the print material being, for example, PLA absorbs water, so depending what you're doing, it may be an inappropriate material for your end piece.
yeah.
But if you print it, mold it, I'm sure you could find something appropriate to use as a cast.
Oh yeah,
And-
you can cast all sorts of stuff. So the other thing I'd kind of do with this as well, Vic, is looking at that design. You might want to share that with somebody, and you want to share it with parameters. So Vic could send me the STL file, but that will only have in whatever Vic set. There is the ability to export what's called an F3D file. So if you go up to export, that's the one. You can save an F3D file. When you load that into Fusion, that then gives you all the parameters and effectively this design, so you can then edit it.
So the way we would share this model with people is we won't do. Oh, where's my window now? Oh no, because this is not my browser. That's not my browser. So we won't do what happened on printables.
Robert says measure diameter but draw radius. Yeah, good point.
There's many ways you can skin the cat. So we are not gonna do this. We're not gonna give you just the STL file that you can download from here. The way we would, so that would be an STL file here. The way we would share it on printables, we would probably give you this file here, so you can import it to your own Fusion, and then we would probably, I did hit export, something happened. And we will probably give you the little description to say, you know, these are the parameters, you know, we'll probably give you some constraints to say, by the way, don't do this or do that. And you can do it, you can then change it to your heart's content, basically, and make a one that fits your need for a choke.
Yeah. The one thing this lacks that's a really nice feature in OpenSCAD. So in OpenSCAD, what people do at the top is they put all their variables and a nice description of how the model works. You can't really do that in here. You could kind of write a note and leave it in the model, but OpenSCAD has that idea of commenting, this is what the variable means, and so you're a little bit limited here in you've got to communicate to people the limits of the model. That's probably the failing. And I'd love parameter sets, because again, what you can do in can you, oh Robin, that's a good question, Robin, can you use Boolean logic within the parameters to prevent breaking it? Sort of. So you can create a parameter that's like a check value. So you could have a thing that said, if my wall thickness minus whatever is under 3 mil, then that's true. You can do a bit of that, but you can't do sort of explicit hard stops. I'd like to be able to set a parameter range and say this only goes between 20 and 60. Maybe we'll get that in a future release, right?
Can't use VLOOKUPs.
Yeah, effectively that's what I'd like, and I'd like the ability to do sets of parameters. So here's my 6 preset sizes. You can just pick one.
So also we didn't do exactly what is here, but the functionality is maintained. So the big
He
thing
uses the
about
lip,
it,
doesn't he? Well, do you want to try the lip? You should be able to do the lip really easily.
Yeah.
Because the
So,
lip's just an offset.
yeah, the functionality was to to try to have your zip ties not being stuck, behind the coax, so you actually can't take them out anymore. It should be easy enough, and if it's not, if you do the print and you still find it,
Well, I think he's got the zip tie cut on the wrong side. I think the zip tie cut should go on the inside.
let's see. That happens, yeah, and then I can just go and change the depth to say 1.5 now, or yeah, so, and now you have kind of a weird looking choke.
That's very square, isn't it?
Very squared out, yeah.
I'm pretty sure the coax will take care of that.
Yeah. Oh yeah, for sure. You could always probably parameterize. Did we parameterize this dimension?
No,
The width.
that's a function of the depth versus the diameter. So I did
Ah, yeah.
think about letting you set the width, and then the depth would get driven.
Yeah.
But that's too. I couldn't make the maths work. You end up having to do a cosine thing.
So
It's
I
the
think-
limit of my brain rather than you can't do it.
it's something that we just come up with, fairly quick.
But again,
But
there's lots of ways you could build this model that aren't the way we've done it. So you could just start with a cylinder and then do everything from the cylinder and slice everything off. And then you could set the width of that, Vic, because the size of the tool that you slice with, you'd effectively create a tool to cut it. So if you thought about like a milling machine, you could use like a 5mm cutting tool to cut that cylinder. That would give you a 5mm cut. You could do it that way round.
Also, when
But
it
I
comes
couldn't
to
work
the
out to do the trig.
when it comes to the height, we could have done something else. We could have said, how thick is your coax, and how many turns do you want, and it will.
So this was my idea, Vic, of rather than doing this by height and width, you tell it what your coax is. You tell it how many turns of coax you've got, and it calculates the height. So if you've got 7 turns of RG58, that means 7 on one side, 8 on the other, remember? And therefore you could work out the height. So what's 8 diameters of that? And that would be your minimum height.
Yeah. So
you could go to
that
town
as
on this, right?
Yeah.
You could go nuts and create all sorts.
You could create another pattern that runs up the tube that is kind of a small recess to guide the coax.
So right,
Depending
Vic,
on
Vic didn't believe in this. Go to just go to create for me. Go to create. There's a thing called which one is it? Is it sweep? Sweep. Go up that one. So you can have a profile. So you could create a spiral and then effectively use the coax to cut it.
Yeah.
Again,
So
I could work out how to do that this afternoon, but you could do it, right? Because you can create. There are things you can create threads, so you could almost do it like a thread cut.
listen, like a massive screw.
Yeah, like a massive screw thread.
Yeah, but inverted.
Like some huge. Is Acme the ones they use for ball threads? Is that Acme thread? I think it is. There's an Acme thread that's like a curved profile. You could cut that in it.
Yeah.
But Vic thought I was going mad at this point.
Yeah, I was like, we are not doing that.
We're not doing that tonight.
Not tonight, anyway.
That comes in the advanced section, right?
Got to say, I've been playing with 3D printer for 3 years now, and I've learned so many little things that I didn't realize. I didn't realize.
Yeah, I would say Acme is normally machine screws. Yeah, but if you think about those ball lead screws, it's the thread for a ball lead screw, whatever that's called. So if you look on a lathe, the one with the half nuts, whatever that is, those lead screws. But anyway, we can have screw thread corner later.
So we actually have come up on an hour.
Yeah, it's a nice round number.
The other thing you could do as well is you could make that hollow. Vic and I talked about this. So the one Vic made was 2 skins with a piece to separate the walls. That's the other sophistication you could do.
I'm just gonna say that I didn't make it. I just got it off the internet. But unfortunately, again, this is just
you could model that if you wanted.
So Also, just to say to you guys, so I got it off the internet, but I made two, and they are different heights. But I didn't touch the fusion for this. All I did is just in the slicer for your printer. You can do that.
You
I could
scale the
also
height, right?
I could also scale them so they're thinner in the slicer again, and stuff like that. So you could have done that in the slicer again. It's a different process because you kind of have to work out, you know, what numbers by what percentage you have to. You have to calculate a proportion of what percentage you need to scale these. But we are also planning on doing something this. So you do double walls, and then that adds the strand to this quite hard thing to actually squeeze. And it's only
Imagine if you did it
1.5.
in the slicer, the problem would be that if you with that kind of model, the support, the connecting points could become too short quite quickly.
Yeah.
That's
At least in this, you've got a lot more control by the
So one thing I wanted to show you. So that's how you make a simple part. I made a part for somebody recently, which was a Yagi boom holder, which, Vic, if I can share the screen, I'm not going to show you how I designed it, but I'll show you that model just so you can see what like the next stage of this looks like. So what a more complicated model looks like if people are interested. Right, I need to grab. I need to share screen, don't I? Right, wait 1 second, caller. Actually, I'm going to do the other thing. What did someone say? Screen share is the way to do it.
Screen share is preferable, yeah.
Okay, so I'm going to go screen share. So with a bit of luck, you should see my Fusion window.
It's like I'm wearing glasses all of a sudden.
So this is effectively just to show you what you can do. Let me turn everything on. So this piece, imagine this is a boom for a Yagi. Let me turn off that one. So that's the boom going this way, and then this is effectively the dipole. So the element goes that way, the element goes that way. And we wanted to create something that would convert a 15 or a 20 mil section aluminium tube, and then allow these 10 millimeter tubes that you can get from B&Q. So if I turn those objects off, so what I did was I created all of those parts as parts to do the fit to, and I use those to drive my sketches. So if I just turn my sketches on, you'll see how we did this. So I'll go right back to the start. So remember we talked about timeline? I'm going to drag my timeline back. So I started here, which is how do you draw those 15 and 20 mil booms? So that's just a really simple sketch. There's a 15 mil boom. There's a 20 mil boom. They're just squares with a filleted corner. So that was sketch one. And then we extruded those to make those effectively those parts, because I use these later to cut my plastic. So I use these as cutting tools. And then I make the 15 mil one. Then the next sketch is then for the elements that run across the way. So you can kind of see that's 10, 8, and 5. And we then extrude that to get our tube. So at this point, all I'm making is tools. Then I cut the gap. So this is the gap in the dipole. So I'm making now all the tooling I'm going to use to cut my bit of plastic. The next sketch then is what's this section? So what does the shape of the holder look like? And I just went for effectively a little bit of a fillet and just to bring it down, just to get a bit more material here. We then extrude that. So that's just a simple extrusion just out, and then I've got that filleted edge. I then did a bit of a this was a bit of a fancy bit, which was basically now to cut using these tubes. So I've cut into there. See the bit still inside? I haven't removed it yet. But the idea is if I go back a stage to here and I take the two 10 mils off, I'm now going to use these as tools. So this operation here effectively uses them to cut that piece out, and then I delete this piece I now delete. Like that. So I've now made that cut using the 10 mil tubes. Now, if I made it a 15 mil tube, I'd obviously have to scale everything out. So if I was going to make this parametric, you could then change the size of it. So I'm now using this geometry to cut the chamfers, a couple more, just a little bit of filleting around the edge, just so it's not quite so sharp. Then we do the middle section. So I bring that piece in between the two elements back. Like that.
Simon, sorry to cut in.
Yeah.
Comment from Eon says, this is really interesting with an exclamation mark.
I'm glad we've finally got to the interesting bit. But you can kind of see how you can take those techniques and bring them on. Again, just extrude over now. So all I've done there is just effectively, I'll show you the extrude. All we've really done is just pulled that over just so it sits inside. This got interesting because you get into fit and issues there. So a 10mm tube from B&Q is not 10mm diameter. It's a little bit more and it's a bit rough. And when you print, that internal diameter is not. So I ended up putting a bunch of tolerance in there to make that fit. In fact, I think that's my tolerance cut. Is that what I did? Yeah, so this just creates a little bit of a gap in there. A bit of a fillet here just to help you ease the tube in. And then I put the screw hole in the top. So that's literally just a hole plunged through. A hole through there. And then these are where you'll effectively put some screws through just to secure into these. And then the last sketch was just to put my call sign on the side. And then we just extrude that out just to give you a little bit of text. So that's the same sort of techniques we were talking about. Now I could go back and parameterize this and make it fit different sizes of tube. So you could say if you couldn't get 10mm tubes, maybe you can get 15mm. You could probably make that design. You'd have to broaden this piece and you'd have to allow for 15mm. And all of these then obviously would offset and get bigger. Is that useful to people for what you sort of can do? And again, that's about a morning's modelling. Printed it, a bit more fiddling, printed a second version, sent it off to Leo, who then came back with a few comments. So we did that in about 3 iterations. And that's the sort of things you can build. And again, there's none of those techniques there are anything harder than we just did with Vic. All right, the shape's a bit fancier, but it's extrudes, it's sketches. There's a bit of filleting just to make it pretty. So it's well within the capability that you've got to do it.
I also think that people sometimes think that you only draw on this kind of flat surface at the bottom, but it's not true. You can draw on all the surfaces of your object.
Yeah,
and
exactly. I sketched on that
dimensions.
Surface there to do this.
It is just another sketch, on just another surface, and then from there you can do quite a lot of things if you just realize that you're not restricted just to that flat.
And this was one I built for Nathan. I mean, this is a bit of I'm not going to go through this in detail. This was a beast. So this was to clamp from a roof bar on a car to an antenna. So he's got roof bars on his car. It's basically going to hold out. Because it's too long for my printer, I had to make these little prongs. So it snaps together into 2 pieces. But this is the whole part. So his pole goes vertically there, and we've got holes for tie wraps. This connects through, and you can secure it with a tie wrap. And then this clamps onto his roof bar. So his roof bars go through, it locks into there, and then we can tie wrap this bracket on. This took a bit longer. This took us about 2 weeks on and off of a couple of nights of figuring out how to make that connect work.
Simon, sorry to cut in. We've got a comment on YouTube from from 2E0 ORD. He says clever stuff.
There you go. So again, you can make stuff like this. This was a bit more sophisticated just because we had to build this interconnect, and the parts we were fitting to were a bit weird. So getting this to work right was a pain in the backside. This piece we added. Originally, we just clamped here. But actually, because they're cheap Halford roof bars, it was flexing. So we put that in just to constrain it and to stop it sliding up and down the roof bar. But this, when you print it in this, even in PLA, you're never going to break that. I think Nathan had a good go. You can't break that. So that's 5 centimeters in that dimension there. And that's about 20 centimeters long. And you won't break it. So yeah, you can make some interesting things, and there's no difficult techniques in there, and you don't need to be able to draw You just need to understand what it is. I want to connect a pole to a roof bar. Well, how am I going to do it? Well, I just did some chunky triangles. Nothing, there's no, people think this is all magic and difficult. It's not, it's just really basic things. But you string it together. Cool, that was all I was going to show, Vic.
Yeah, there you go. I'm not going to show anything else either, but
I suppose, questions really from everybody.
Open for questions now, and one or the other way.
Has anyone got any ideas that they don't know how to do, they want to talk about? That's the interesting bit. Is there anything anybody wants to make and they don't know where to start?
How did you even start? Because that's been one thing on the back of my mind, is how you connect multiple pieces together, especially with things like even just little things, simple things like boxes and making the right kind of connections. And so keep going back to like GCSE, CDT kind of.
Do you want to know what I've got? I've got a Japanese woodworking book. Go back to woodworking technique. So if you look at Japanese carpentry, it's all about angles and slots, and it's a lot more sophisticated than ours. I've got a Japanese carpentry book that has all sorts of weird joints. Because don't forget, plastic's quite pliable. You can snap things over. You can make snap fits. So if I go back to that picture, go back to the antenna mount quickly. Hold on, screen share. This is snap fit. So I don't know what will come out. I've got these little bits here that come out. Inside here, if I make this opaque, wait 1 second, caller. I need to do this one. So if I make that, I've got little grooves. So this slides in, these flex a bit and they slot into there. So that snap fits together. Snap fit in PLA is brilliant because things will move a couple of mil. I made a case with a snap fit lid. Where is it? And that's just tiny little things that just flex a little bit and snap together.
I assume the prongs are just a little bit narrower than the holes, and it just
so that's just a bit wider.
Yeah,
and they flex just a tiny bit. It's here somewhere.
Also, when you're making this, you're very likely to design something, print it, try to fit it, and it's not gonna fit.
Yeah.
I remember, I think my first 3D design was
mini disc display stand.
No, my first 3D design was just a box extruded, like a round box for storing the 240 toroids, and I made the inside of the cap for this tube the exact diameter of the tube, and I could not open it.
So this is for a diplexer. This is a snap fit case. So the two halves. See again, I've just got those little prongs, and they just fit into those recesses. So snap fits work really well. Just any kind of joinery technique will work because you can always glue stuff. But I would have a go at snap fits because
they look
PLA is brilliant for it.
Simon, sorry mate, there's a question from Owen. When you were designing the roof bar parts, were you thinking about the printing at that stage?
Yes. So there's two things about 3D printing. One is layer lines. You've got to think about what orientation you're going to print this in. So it was going to be flat on the bed like this, which meant it's very, very strong in bend, but that's fine. So what you wouldn't want is to print like this way up, because then as you bend that way, it would snap. So you've got to think about the layer lines. The only other thing I would say you need to think about for PLA is if it's going to be out in the sun, be aware the sun will destroy it. So if you're making parts that are going to last 5 years, don't use PLA. Feature size is another thing. Do not do small, delicate features. They'll just snap. So there's like a minimum size I'm going to make those prongs. In that diplexer snap fit, I know that size just about works. And I think that's 1 mil deep, 4 mil across. Any smaller and you will break one of them. So there's sort of a minimum size for those sorts of features. But yeah, you do need to think about the material. Usually the orientation you're going to print it. So I try and make things that don't need supports. So this, for instance, you print it on its back. It doesn't need supports. That didn't need supports because you can print it on its bottom side, put a bit of support inside there. The Yagi holder prints without supports. You print it on this side here. So you print it effectively that way. And that doesn't need, you put a bit of support inside, but that's it. So yeah, you do need to think about material. You do need to think about orientation. But you can get away with a lot. It's rare that the design's driven by it, but there are a few things like overhangs is the one I would say. So the reason I chamfer things is not for aesthetics, it's to make it print better. So if you print that on a flat surface and you have a hard chamfer, it's like an overhang. Whereas if you have a fillet or radius, you get a better edge on it. So you do need to think about things like that. You don't want to create massive overhangs. Like you couldn't print that way up. That overhang wouldn't print. So you do have to think about that. Does that answer the question, Owen? Cool.
Yep, it says yes.
Yeah. Any more for any more? But yeah, Japanese carpentry books are my recommendation for joints.
Fair enough. The snap fit does look very, very easy, and to be honest, very easy for me to just quickly throw together a small box.
Yeah, there's a very good Adafruit video. So Adafruit once a week have a 3D printing thing. It was about 4 years ago, and they built a snap fit case. It's where I got the inspiration. I don't do it the way they do it, but I got inspired. If you look for 3D print snap fit Adafruit, there's about an hour-long video where they show you the whole process in Fusion of making snap fits. That's brilliant. It's worth watching. You won't do it the way they do it. You'll find your own technique, but they talk a bit about like how you do it and how you do the cutting. So I use the snap fit as the cutting tool. So there's some clever things you can do with the technique. So you don't have to draw all of that geometry. It's actually, well, I'll quickly show you. It's actually a draft angle. So it's an extrude with a draft angle to make the point. Because you think, oh, how'd you draw that triangle? Well, you don't. That's the trick.
Thinking as well with the snap, so if it was like in a box, you could leave gaps on the bottom of the bit it connects into to help you clip it off.
Yeah.
When you want to take it apart and that kind of thing. It's just that kind of detail.
So that isn't a triangle. That's an extrude with draft angle on it. If I can find the feature, wait one. Oh, which one is it? It's later. Is it that one? There you go. So if I look at this, that's it. So if you look at that feature, that's actually a straight pull, but then you put a minus 45-degree draft angle, that makes it come together. So if I set that to 0, it comes out as a solid block. When you do minus 45 draft angle, it makes it that prism shape. So it saves you a ton of work.
Just extruding a square, sketching a square, sketching a rectangle onto the leg, and then extruding it a couple of bits. Minus 45.
You just, exactly, and then you use that as the cutting tool into the other side. So you don't have to. It's not. I'm not creating every surface. There's some real nice shortcuts you can do.
That's cool.
But yes, for things like cases, it's just the way to do it.
If you're on the Discord server, obviously there's the 3D printing channel, which you can obviously ask questions in, and lots of people with a lot more knowledge than I have.
Yeah, and if you want to make something, just hang around in there and ask stupid questions, because one of us will get inspired and make it for you probably.
Yeah, that's
how a lot of things happen. Someone says, "I don't know how to do this," and someone will go, "Hang on, I've done it." So yeah, it's a good channel if you want to know where to start. Just ask a question in there, and someone will probably help you.
That's the story of the whole server, Simon.
Aye. Yeah, but we're really good. We've made actual things. It's a bit like antennas, actually. Antennas is like that as well. There's nothing like, oh, I can't do this, and then 15 people compete to do it for you.
We've built a network in a month.
Exactly. And you can make things like that as well. We made that.
Oh yeah.
You're going to have to make the Irish one now. We've got the Irish call sign.
Oh, hang on, he's got one. Have you made one?
I haven't.
Oh, I thought you were going to do one.
I think we should make one. We should make one. We should stream it, Simon, like we did.
Well, if we do another one, maybe we should make one of those, because importing STLs and SVGs and things to make logos is quite interesting.
Yeah, we should.
Maybe that's the next one we do, right?
Yeah.
Assuming people want to do another one.
Exactly.
No more comments from
YouTube.
Yeah. Any last questions, requests?
No, we've been running consistently with 12 people on YouTube, so it's been well attended. No one's disappeared. Just lots of positive comments.
Good. I hope everyone found it useful
and
you're inspired to make something.
We've got a comment from Paul. Sounds like a pub play night.
Paul gets upset when me and Vic do 3D design on pub nights.
We have to go to the separate room.
Yeah, we get sent to a room.
Someone else says indeed with a smiley.
Yeah, that's just yeah.
That was Jonathan.
Pub night,
Jonathan.
You'll often find Vic and I sat in a breakout room making things because we're weird. Cool. I think we're going to call it quits then.
Yep.
Thank you.
Goodbye, YouTube. Thanks for your comments. Like, share, subscribe, click, join us.
Join us on OARC.
Just before we call it a night, Pete Doherty says, "Brilliant, thanks everyone."
Good. I'm glad people enjoyed it.
That was a comment from YouTube.